Hello, hello, it's Mr. Slope Guy, and today we're going to talk about factoring completely. And prior to now, you should have done some methods of factoring, like difference of squares, perfect square trinomial, a method of listing the first and last factors, and checking by multiplying a binomial times a binomial to make sure it comes out to be equal. So you should have a little bit of history with factoring, but today we're going to kind of put it all together to factoring completely. And we're going to start with steps to factoring completely. And you're going to want to write these down to be able to refer back to them. Step 1, factor out the greatest common factor. Factor out the GCF. Step 2, is a polynomial a binomial or a trinomial? So we're going to look for either a perfect square trinomial, if it's a trinomial. If it's a binomial, we're going to look for difference of squares. Step 3, if there are 4 or more terms, we're going to group the terms and factor out any common polynomials. Step 4 is to check that each factor is prime. So our final answers, if we just have binomials left, we're going to want to go through and check and make sure there's still no GCF and no difference of squares to make sure each binomial left is prime. And you can always check your answer by multiplication. And when you're factoring completely and you have a trinomial, you want to check for like traditional factoring or trial and error. Your teacher may have different names for what those are called, but basically you're looking for a method that you look at all the factors of the first term, all the factors of the last term. You try some different combinations to make sure if you multiplied out a binomial times a binomial using a method like FOIL, first outside, inside, last, that you would get back to the original problem. So let's start with an example. We have 2x squared plus 8x plus 8. Step 1, the first thing we're going to look for is GCF, the largest number that will divide into all 3 of these in the trinomial, and the largest amount of the variable that they all 3 have in common. In this case, we have a GCF of 2. If I pull that 2 out, I'm left with x squared plus 4x plus 4. And we are not done yet, because our trinomial, x squared plus 4x plus 4, can be factored again. We have a trinomial, so we're going to check for perfect square trinomial. Is this a perfect square? Is this a perfect square? If I take the square root of x squared is x, the square root of 4 is 2. If I multiply it together and double it, I get 4x. So it is a perfect square trinomial. So I could factor it again. I have to bring down the 2 because it needs to remain equal, but I factor this trinomial as x plus 2 quantities squared. Then I can double check and make sure that these factors can't be factored again. So x plus 2 doesn't have a GCF, not a difference of squares. 2 is fine. All right, new example. Let's look at 5a to the third minus 20ab squared. First thing we're going to check for is GCF. If I pull out a GCF of 5a, then I'm left with a squared minus 4b squared. So we have a binomial left. We've already pulled out a GCF, so next I'm checking for difference of squares. Is this a perfect square? Yes. Is this a perfect square? Yes. Is this subtraction? Yes, it is. So it'd be a minus 2b and a plus 2b. Bring down the 5a. Then just double check each of your terms. Make sure this term, no GCF, no difference of squares. This term, no GCF, no difference of squares. And the last term, no GCF, no difference of squares. Then we know we have factored completely. And we could multiply this out and get back the original problem so we know it's equivalent. How about this one? 32x to the third minus 16x squared plus 2x. Start by pulling out that GCF of 2x. Remember, when we divide 2x by 2x, we have to have this positive 1 here because it has to be equivalent to the original problem. Then I'm left with the trinomial, so I want to check for what? Perfect square trinomial. Is this a perfect square? Yes. Is this a perfect square? Yes. If I multiply 4x times 1 and double it, do I get 8? Yeah. So the middle term works. So it's the square of the first, square of the last, sine of the middle, quantity squared. So I bring down my GCF of 2x, then I have 4x minus 1, quantity squared. So if I just stopped at this step on test day, I would get this problem wrong because it is not factored completely. You got to keep factoring till you get to the point where it won't factor anymore. If I look at factoring this again, I'm like, oh, look, it's a perfect square for 1. It's subtract, but 4x is not a perfect square because I don't have a 2 on the x squared, so it won't go any further. So you're always going to want to check your final answer and make sure it will not factor any again. All right, how about this one? 18x to the 4th y plus 15x to the 3rd y minus 12x squared y. First, I'm going to pull out that GCF of 3x squared y, and I'm left with 6x squared plus 5x minus 4. Is this a perfect square trinomial? Well, with the 6 here, it is not a perfect square trinomial. So now I have to look for a method of listing all the factors of 6x squared, like 6x and x, or 3x and 2x, and all the factors of -4, like -4 and 1, or -1 and 4. So I have to look for a different list of factors, and I can go through, and if I go through my list of all my different options, the one that works is 3x plus 4 times 2x minus 1. Now I can go through and check. Does this have GCF? Nope. Does it have difference of squares? Nope. How about this one? 3x plus 4 GCF or difference of squares? No. So all 3 of these factors we're left with do not have a GCF or difference of squares, so we are completely done factoring. All right, you guys try this one on your own. Try 3x to the 9th minus 48x, factor completely, and when you're done, unpause the video, come back, we'll see how you did. Oh, welcome back, everybody. So let's first start with, let's pull out that GCF. The GCF was 3x, and that leaves x to the 8th minus 16. I have a binomial. I have a perfect square, and subtraction. So I have difference of squares here. So this will factor as x to the 4th plus 4 times x to the 4th minus 4. And if you stop there, you got it wrong. Oh my gosh, what do you mean you got it wrong? Well, one of these factors will factor again. Perfect square. In addition, the sum of squares is prime. The sum of squares will not factor. But perfect square, and subtraction, this is difference of squares, so this term will factor again as x squared minus 2 times x squared plus 2. This one will not factor again. Then I can double check, do I have difference of squares again? No GCF, no difference of squares, no GCF, no difference of squares. So this is completely factored. So do not factor the sum of squares, it is prime. All right, I hope that helps you guys get started on factoring completely. Have a great day. OUT spells out.